So in the last video we talked about arithmetic sequences in series, which you find by adding or subtracting a term to each previous term. Geometric sequences in series are when you multiply. So we're going to get to that here in a second, the actual definition of it. But this is just very similar to what we were doing yesterday. It's just a different form of finding the terms. So a geometric sequence is a sequence in which you multiply each previous term by a certain non-zero constant. And that number, similar to the common difference we had yesterday, is called the common ratio today. So it's a sequence in which each term after the first is found by multiplying the previous term by a non-zero constant. And that non-zero constant is the common ratio. Alright, so to find the nth term of a geometric sequence, use this equation where r is the common ratio and a sub 1 is your first term. So when you say that you want to find the 100th term, you would take 100 minus 1 and get 99, and you would raise, because you have r that many times, multiplied then ultimately by the first term that you have. So let's go ahead and take a look at finding one of these. So it says find the 8th term of a geometric sequence for which a sub 1 equals negative 3 and r is negative 2. So if we jump to our formula, we have a sub n is equal to a1 times r to the n minus 1. So we have a sub 8, because we're looking for the 8th term, is equal to a sub 1 is negative 3, r is negative 2, and then it's to the 8 minus 1 power. So we get negative 3 times negative 2 to the 7th. So negative 2 to the 7th power is going to be a negative. So let's see, we'll keep the negative 3 there. Negative 128. Then multiply that by negative 3. That's 6. It's going to be a positive 384 is the 8th term of that geometric sequence. Now this time they want us to write an equation for the nth term of a geometric sequence. So we're going to use the same formula that we had before. It's just this time we're going to plug in values and we're going to have to write the equation for it. So we want to figure out what am I multiplying by each time. So from 3 to 12 we're multiplying by 4. From 12 to 48 we multiply by 4. So on and so forth. So our r value is equal to 4 and our a sub 1 is the first term, which is 3. So then a sub n would be equal to 3 times 4 to the n minus 1 power. That's all that's to it. Now this one's going to be a little different. We are still going to use this equation a little bit. We have to go back and almost find, so they want us to find the 10th term. We almost have to go back and find the a sub 1 so we can use our equation, because we know what r is, but I need to know what my a sub 1 is. So we know a sub 4 is 108. So we would say 108 is equal to a sub 1 times 3 to the 4 minus 1 power. So I get 108 is equal to a sub 1 times 3 cubed. So that'll be 108 is equal to a sub 1 times 27. So divide by 27. We end up with a sub 1 is going to equal 4. So our first term was 4, and then we're multiplying each one by 3. So then when I want to find the 10th term, we say a sub 10 is equal to 4 times 3 to the 9th power. Now I'm not going to sit here and figure out what 3 to the 9th power is. which is what your calculator is for. So we have 3 to the 9th, which is 19,683. And then we'll multiply that by 4. So our final answer would be 78,732 is the 10th term of that geometric sequence. So then we move on to geometric series. So geometric series, similar to the series from yesterday, again is a sum, but this time it's just of a geometric sequence. So it's a very similar definition to what we had yesterday for arithmetic sequences, or arithmetic series. In the formulas, we have 2 different formulas, just like we had yesterday. The first one is a sub 1 minus a sub 1 times r to the n divided by 1 minus r. And then the second one is s sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. So it's really the same equation that is factored out that a sub 1. So again, either one will give you the same exact answer. Alright, so this is the summation notation that we didn't get to, the sigma notation that we didn't get to yesterday, or in the last video. So with this is telling you to start at the first term and go to the 6th term. So this is wanting the sum of the first 6 terms of a geometric sequence. We know it's geometric because there's multiplication going on here. The term that's raised to the nth power is going to be your r value. So we're seeing that r is going to be equal to 2. And then a sub 1 is found by doing 5 times 2, and then you substitute in 1. 1 minus 1 is 0, 2 to the 0 power is 1, so this all ends up being just 5. So when I plug in, we're going to do s sub 6 is going to be equal to 5 times 1 minus 2 to the 6th all over 1 minus 2. So we get 5 times 1 minus 64 all over negative 1. So we get 5 times negative 63 divided by negative 1. And so that will end up giving us, let's see, 5, a positive 315. Alright, so they want us to now find, so same idea, but this time they just give us, this time they give us an a sub n, and we have to find out what term that is so that we can figure out what's going on here. So just find the sum of a geometric series for which a sub 1 is 15,625, a sub n is negative 5. So really what we have to do is figure out what term that is so I can find the sum of this. So we're going to have a sub n is equal to, we're going to go back to this equation to figure out what n is. So we know this a sub n is equal to negative 5. I mean 15,625 times negative 1/5 to the n minus 1. So I divide by 15,625. So we end up with negative 1/5 to the n minus 1. And over here, when we reduce this, we end up with 3,125. Well, negative 1 over 3,125. So now really what we kind of want to do is figure out 3,125 is 5 to the what power is one way of doing this. So it's 5, so we can say this is going to be -1, and it's to the 5th power. So then we know from our exponent rules from a couple of chapters ago that n minus 1 is equal to 5, so that n is equal to 6. So this is the 6th term, and now I can actually find the sum of that by saying s sub 6 is equal to the first term, which is 15,625, times 1 minus -1/5 to the 6th power, all over 1 minus a -1/5. So when we do all of this, we're going to end up with 1 minus 5 to the 6th power is 15,625. So we end up with 1 minus 1 over that, all over 6/5. Now if you distribute this and use the other format of that, we end up with 15,625 minus 1, all over 6/5. So we get 15,624 over 1 times the reciprocal of this, 5 over 6. So then 15,624 divided by 6 gives us 2,604 times 5. And our final answer is 13,020. I apologize if it's a count at the corner of the video there. So I just distributed through that 15,625 to both of these. And I'm getting 15,625 minus 1, reduced it, divided by a fraction, which means you multiply by its reciprocal, reduced, and ended up with 13,020. The last question they have for us here is they want us to find a sub 1. So now we might be using a combination of these equations to find a sub 1. In geometric series, for when they give us the sum is 39,360, and then r is 3. So we're going to start by substituting into our sum formula. So we're going to know that it's equal to 39,360 is equal to, we need to find a sub 1, 1 minus 3 to the, we know we're on the 8th term, all over 1 minus 3. So we can use this equation and just solve for a. So we have 39,360 is equal to 1 minus 3 to the 8th power all over -2. So let's find out what 3 to the 8th power is. So let's see, 3 to the 8th gives us 6,561. If I multiply both sides by -2 to eliminate that, we end up with a sub 1 times a -6,560. And over here we end up with 0, 12, 6, 7, 8, 6, 7. 78,720. We divide both sides by -6,560. Oh, and that should be a negative as well, because it's a -2. And then we end up with a sub 1 is equal to 12. And that wraps up sections 3 and 4 of chapter 11. So make sure you have the correct assignments for the correct pages for those two sections of assignments.